I'll do it correctly this time. So welcome. It is, what is it, Monday. It's August 3rd. There was a full moon today. Here we go. Well, I can't do it as a bonus question because Aaron will know the answer. Does anybody else know what the full moon's name was today? Every full moon has a name, apparently. Like Henrietta, Gertrude. It was the full sturgeon moon because this is something to do with all the sturgeon come out. I don't know. But anyway, there was a full moon this morning. And I personally always feel better after the full moon happens because I think the gravity lightens up. More babies are actually born on full moons than any other time in the month. So Joey was a full moon baby. And yes, I don't know if Janae, any of hers, you'll have to see if any of yours were. So questions that came up, one is I'm wearing my Knopf. So those of you who've been with me, so my gnome hat, and it's rainbow because you guys have your rainbow cabbage due today. And it was a question Sam asked me, and then somebody else asked me, and you're all probably gonna ask. It has you do color blending, and it wants you to take something that was red or pink and mix with something that was yellow. And probably at least half of you, if not 98% of you, did not get the color yellow. And that would be my bad. So just pick any two different colors, like a red and a blue, and mix those and see what color you get, and then comment on that. To get yellow, if you're aiming for yellow, you probably have to have Drano, or you can Google it. And many of you probably don't have it. So I wanted to talk about the exam. The exam is indeed Tuesday. I sent an email out, I think last night. And since I didn't get any responses, I'm assuming you guys are all getting emails. I'm going to do the exam at 2 different times. So there's 2 parts to the exam. One part is multiple choice. So we'll just say MC, and that you can do anytime between noon and midnight. So 12 to 12 tomorrow. It will activate suddenly, and you get 30 minutes. So you can't really go in and see, hey, what's it all about? Once you activate it, it starts, and you have to finish it in those 30 minutes. So just go in and be prepared, and you can do it at any time in that range. You can't start at midnight because it will lock you out. So you want to start by 11 o'clock at night so that you don't run into stuff. It is multiple choice. It should not take you 30 minutes, but you do get 30 minutes. And yeah, and the other part is show your work. So the multiple choice is 20 questions. A lot of them will only take you 10, 20 seconds to answer, so don't overthink them. Kind of like the post lab today, a lot of people have asked really good questions. They just wanted you know, like, what do all the cleaning solutions have in common? Soaps are supposed to be bases. We've been changing them, but the show your work is, right now it's 3 pages. I may make it 4 pages just to give you more space, because some of you like to write big. I'm not sure though. And so it will, I'm either gonna do it at 12 o'clock, so 12 noon. You are more than welcome to come. If you're ready at 12 noon, you're like, I just want to do it and get it over with. You do need to come to Zoom, and that's how I'll know who's taking it. And when I see who's there, I will email it. I'm frowning because I just got locked out of my MHCC for some reason today. But we'll figure it out. And it will come to you email. If you have a printer, you can print, or you can just pull it up on your screen and do it on a piece of paper. And then it will be due 90 minutes later. So we'll say 1:30-ish. It might be like 1:35, depending on what time I send it out. And you'll just upload it like you've been uploading your study set. They'll be under assessments. The multiple choice part of the test you'll take under assessments, and then the test here you'll upload under the second part. Those of you, there's a number of people who work during the day. And so the other time I will be is at 6 p.m. If you don't take it at noon, it will suddenly show up under handouts. So you have a folder that says exams, and it will suddenly be in there at 6 o'clock, and it will be due at 7:30 that you'll upload it. So again, it's up to you. You can print it if you like printing, or you can do it on a piece of paper, but I ask if you do it on a piece of paper that you make it set up just like it looks like for you. The show your work, just like on the worksheets and the study sets, and what I will be going over today, because it has always been all show your work, it is being able to show it in a very logical sequence, as well as getting to the right answers. So what we'll be doing today, and I'll point out things that could show up more in the multiple choice. The reason I'm doing some as multiple choice, this is more for the 8 of you who've been with me. Your final is multiple choice, and so I want you to get used to being able to answer things in multiple choice so it's not intimidating to you in any way. So before I start doing the practice exam, are there any questions? And I do have an office hour tonight at 6 o'clock. You can always come to ask questions. I'll be here at 11 o'clock tomorrow. And then tomorrow, I said 5. I might be a little bit late. Just I'll be here around 5-ish. So if you have questions you want to ask. There was a question Joseph had asked me earlier. During the exam times from 12 to 1:30 and 6 to 7:30, my Zoom will be open. Only one person at a time will be allowed into Zoom. So I am available to answer questions that you might have on the test. I will also answer if you have other kind of questions that you want to ask me, but if somebody else comes in or somebody else wants entrance, you will get kicked out. You have to remove yourself, because if I kick you out, you can never come back in. I learned that the hard way last term. All right, let's go through the practice exam. I recommend for all of you, you do the practice exam, even try it again. And I actually recommend you redo your study sets, because that will give you good practice at showing your work, things like that. So let's go ahead and go through this. And if there's other questions you can ask, or you can ask later. I can put this closer to, so to remember to keep looking. I did put answers for most of them. And normally when I do this, I give you guys like 20 minutes to try each page, and then I go through it. But I'm going to go ahead and go through the first page. And then if you guys want me to give you a break so you can try the page, I can pause the video if you want to try it before I go over it. This first question, it is the Hess's law, where you have to figure out how the two reactions will give you the final. The overall is what we're trying to get to. And so the first equation is fine, because it has the tin oxide and the tin. And it is just one of each, and they're on the correct sides of the equation. So I'm not going to touch that one. The second equation, it has the carbon monoxide and the carbon dioxide, but they're on the wrong side. So I'm going to have to flip them. And not only am I going to have to flip it, it looks like I have to double it. So I'm just making a note over there so everybody sees. So it's up to you. This, when I flip and double, it becomes this. And then the two H2Os will cancel and the two hydrogens will cancel. And I will be left, everything will be how it should be. So that means this K becomes to the -2 power. That's one way you can write it. So when you flip an equation, the K becomes to the negative, or you can write it as, the other way you can write it is 1 over K2 squared. I mention that because you might see this question in multiple choice, and it might show everything as variable form. So writing it as K2 to the negative 2 or 1 over K2 squared, that's saying the same thing. And then a question that came up during office hours by a couple people, when we add the equations together, you actually multiply the k's. So again, there's two ways you could write this out. You could say, I'm doing K1 divided by K2 squared, or you can say, I'm taking K1 times the K2 to the negative 2. You can write it out either way. Now, with multiple choice, it's either going to keep it in variable form, and so either these would be the answer. It wouldn't have both, obviously. And if it's show your work, right, you would show your work, you punch this in, and my answer is 13.5. This one actually was the first question on their test last year. Question B then says, based on your answer, this K is greater than 1, so it likes the products. So product favored. And just a reminder, K is equal to the products over the reactants. And so that is why when K is larger than 1, the numerator is favored. If K was less than 1, like 0.0013, then the denominator, the reactants, be favored. So again, those questions with that. If it was a question that came up earlier from Aaron on question B, let's say this shows up on the show your work. This is all I'm looking for in your answer. K is greater than 1. When I say explain briefly but elegantly, keep it brief. That's all I'm looking for. And you could have circled product favored up there. I just wrote it out. All right, Le Chatelier's. Le Chatelier's is in both show your work and in the multiple choice part. It just keeps showing up because it's probably one of the most important concepts we work with this term. All right, and you guys had a lab with it. You should be feeling better. And so nitrogen is added. Nitrogen's a reactant, so it's going to shift it forward. And if the ammonia is removed, ammonia is NH3, that's going to shift it forward. Now let's say you didn't know ammonia was NH3. Actually, hopefully you all do know that now. Ammonia is NH3. Ammonia has shown up a lot in our first week of class. It is a base. And so if we take away the product, it shifts forward. All right, for temperature, you look at the delta H. So we'll write a note here, look at delta H. You don't have to write that, but just a reminder, my delta H has a negative. So there's a couple ways you can think about this. It's going to go reverse. So negative means it is exo. And this is a question everybody asks every year. The delta H is always given for the forward reaction. If the forward is negative, the reverse is equal but opposite. So it's exo in the forward, it's endo in the reverse. There's only two directions, there's only two choices. And so again, the delta H is telling you what happens in the forward direction. Heat always favors the endothermic direction because endo means into or absorbing the heat. So when I see I'm adding heat, it's going to move in the endothermic direction. Ice would make it go the other way. To me, that's the easiest way to think about it. Heat favors always the endothermic direction, so that's why it goes reverse. The other way you could think about it is if this is exo, it means heat is exiting. That would mean heat is on the product side. So that's what exothermic means, is heat is exiting. So it's just like A and B. If I add more heat, heat's on this side, I have to use it up. Can't go forward, there's a wall there. So it's gonna go reverse. All right, so that's with heat. Pressure, you look at moles of gas. So you look at gas moles. And this one, a reminder, and I just realized this, on this practice, I'm pretty sure everything is gases. So we're not crossing anything out, but when I taught this and it was on your study set and your worksheet, if you see a solid or liquid, make sure you cross it out because solids and liquids have no effect on equilibrium. All right, so there is 4 moles over here. We're looking at the stoichiometry, so we have 1 nitrogen and 3 hydrogens. And over here we have 2 moles. So pressure, you're gonna always, pressure's doubled means you're pushing it, so you're gonna push it, in this case, forward. So high pressure pushes to fewer moles. So high pressure, you go to fewer moles. And again, it's fewer moles of gas. This was on the lab that you guys all turned in last week, and I'm pretty sure everybody got that one right. A reminder, volume. Volume and pressure are opposite. So a high pressure means a low volume. So that makes actually even more sense for most students. If you have less space, less is gonna fit into it. So it would, again, move forward. So high pressure, low volume is always related. And then the last one is no change. Catalyst speeds up the reaction. And this is actually back to the very first thing I may have said about equilibrium. And I think Harrison had asked me about it and Aaron also. What equilibrium actually means, and if you Google it, it's a definition you'll get for chemical equilibrium, means that the rate of the forward equals the rate of the reverse. That's what equilibrium means. It doesn't mean that the products and the reactants are equal. They're not, because our K is not 1. It means that the rate is equal. So what does a catalyst do? Catalyst makes things go faster. You probably learned about catalyst back in Chem 222. A catalyst makes both directions go faster. So you're going to speed up the forward and you speed up the reverse. So it has no impact on equilibrium. All right. F, you'll definitely see this question. That would probably be in multiple choice. It would give you the equation. Actually, let's go back over the top one, number 2, A through E. So in multiple choice, it would say which one of these changes will shift it forward. And so you would say, or I'm sorry, which one would shift it reverse? You'd say, well, that goes forward, that goes reverse, and you go, oh, it must be C. And you can look at the other ones. So that would be a way you would see it in multiple choice. Another way would be F, where it just gives you the equation and it says what temperature and pressure to make it go to the product. So they're always asking, how can we make this go forward? So exothermic, we want low temperature. So low temperature, and we already said high pressure would go forward. These two variables are not related. You can have high, high, low, low, high, low, low, high. So we want, it looks like 3 is my choice. It's a low temperature and the high pressure. So sometimes it gives you numbers, sometimes it will just say low temperature, high pressure. And then G, and oh good, there is another question. That was the question I was looking for. What happens to the value of K? So the temperature is decreased. And then it wants you to explain. So let's go simple, brief. Decreased temperature, which way does it shift? Well, high temperature, it went reverse. So low temperature, it's going to shift forward because it's going to try and make more heat to recover what it just lost. And if it shifts forward, that's going to increase your products over your reactants. Back to a question that came up earlier, K is a ratio. If you shift forward, you're going to have more products. That's going to increase your K. When I ask you to explain, and for those of you new to me, which is most of you, I ask you to explain periodically throughout the test. Arrows, symbols, chemists, mathematicians, physicists, engineers, we work in symbols. So low temperature, it shifts forward. We have more products, so K increases. What would happen if it had shifted reverse? Well, the opposite. So if it had gone the other way, we'd have less products, so the ratio would decrease. So you can think about that. I'm pretty sure I asked that in the study set. So going back and actually do the study set again and then look at the answer key. And that's why I'll be available to answer questions during office hours. There was one other thing I wanted to point out again here. You know, Aaron told me he was going to do a very noble thing, which I think it's amazing. He was going to re-listen to the videos. The first lectures probably will make more sense now because you actually have explored this. And so if you have the time and you actually have the ability to listen to my voice for that many hours over again in the next day, many blessings to you. But Janae's laughing. You know, I had an uncle one time who said that I had a squeaky voice, and so that's probably, it's those things people say to you and they shouldn't. But anyway, I can help. If you're having trouble falling asleep, I recommend just put my videos on and listen. Maybe you should all do that. You know how you pick up things subconsciously in your sleep? And so all of that will be in there. God, it's funny. The only thing that changes K is temperature. I remember talking about this in the video, and it probably made absolutely no sense because you were so brand new to it. If you change anything else, everything shifts to get back in balance. That's the ice charts we're going to make on the next page. The K is a constant depending on the temperature. K does change with temperature. Pressure and volume, you're changing the concentration. And so again, it shifts to get back in balance to keep the K the same. All right, this other F is a really important question. And it wants to know which of these will increase the hydrogen. So again, in the multiple choice, it could ask you which of these changes shifted it reverse. In this case, the hydrogen is in the reverse direction. So if you go in the reverse direction, that means you have a higher hydrogen. I want to caution you here because there were a few of you on your lab, and I tried to elegantly say, don't overdo this. Higher hydrogen concentration is the effect. Up here on A through E, these were the causes. So here we caused the shift to happen. Here, this is saying you have higher hydrogen because of a shift that has already happened. The shift happens once and stop. Just stop there, or else you're gonna be in a nightmarish world. So the only one that shifted reverse was C. So C shifted it reverse, and that would make the hydrogen go up. Does that make sense? A, B, and D would make the hydrogen decrease. because they shifted forward. And I mention this because you might see it as a multiple choice question where instead of saying which will shift this way, it might ask which one would result in more hydrogen or a higher hydrogen concentration. And also in the show your work, sometimes I just ask for forward reverse, and sometimes I'll say, hey, what happens to the hydrogen? So if I'd asked what happens to the hydrogen, I recommend you always do your arrows, and then this would increase the hydrogen, this would increase the hydrogen, this would decrease the hydrogen, and that would increase it. Does that make sense with the arrows? That was a lot of words and a lot of information. So I'm going to take a deep breath, see if anybody has a question.
Ms. Sherpa?
Yep.
Wouldn't the first two decrease the hydrogen?
I just did it completely backwards. You're right. I said it right down here. So maybe that, you know, Erin, thank you. I had my first year in college, your first class is chemistry, general chemistry. And the teacher said if you, he was going to make a mistake every class on purpose. And if you caught the mistake, you got a Snickers bar. And the very first day I taught 25 years ago, yeah, I made a mistake and I just started laughing because I finally understood. The teacher just knew he was going to make a mistake. So if I could, I'll throw you a virtual Snickers bar. Did you catch it? So yeah, thank you, Erin. I just did every single one of those backwards. You know, it's back to like what Sam was saying earlier, the videotaping actually also messes me up. So everybody fix that. The A, B, and D would decrease the hydrogen because it's shifted forward away from the hydrogen. And then C would be the only one that increased the hydrogen because it's shifted reverse. Thank you so much. Anybody else?
Hi. So I think G also increases the concentration of H2 because of the heat. So if it's when we increase the heat for an exothermic reaction, it'll go in reverse. But then when we do the opposite, so the Kp value gets decreased. That's a partial pressure, and then so the reaction shifts back.
I'm really sorry, I don't understand what you're asking. So are you asking about temperature or are you asking about pressure?
When we increase the temperature for like this exothermic reaction, increasing the temperature, doesn't that push back
reverse?
Okay.
And that increases the value, increases the nitrogen and the hydrogen, and it decreases the NH3, and that changes the value of K.
Gotcha.
So temperature always changes the value of K.
Gotcha.
In the question G, I decreased the temperature, so it shifted forward. Everything else that compensates, so only temperature changes the value of K. Yeah, I hope that helped.
It does, thanks.
All right, anybody else? All right, let's do the one bum page. And it's a whole bunch of numbers, which means we're going to make an ice chart. So you guys know how to write ice. So write your chart and let's fill in. Oh, wait, actually, I don't need an ice chart because I just read the question, the first two words. So you can write your ice chart and then you see you're at equilibrium. So as soon as it says you're at equilibrium, we're there. We're where we want to be. We're ready to plug numbers in. So you don't need the ice chart. Now something several of you did, I think it was on the lab because I was grading the lab the other day. You do need to write your K expression. So products over reactants. So on the show your work with these, quick comment, this equation shows up a lot. in the problem that you are solving, the K has to go with how the equation is written in that problem. I caution you of that because you are all in a situation I have never found myself in before, which is you can sit there and say, oh, I have all my notes right here in front of me. And that may actually be a deterrent. I would study. You can have your notes in a folder next to you in case you get in a weird mode, but take the test as if, actually take the test because you all know this. If you study, you're gonna be fine. So products, SO2 and the oxygen, you square them, and then we just plug in our numbers. So the 0.50 moles in 2 liters. Now I'm plugging it in like this. You can actually figure out, okay, that would be 0.25 molar. But just a reminder, we're plugging in molarity unless I specifically tell you you're doing a KP, and then you would be doing ATMs. My oxygen is 1.50 moles over 2 liters. And this would be 2.5. And that is squared. And you punch it in, and we should get that K equals 0.030. K itself does not have a unit. I want to mention that is true for our class. Some of you are going to move on to higher level chemistries, and depending who your teacher is, some teachers like to put units on K, and you can worry about it at that point. It's simple algebra to put the unit on. Do notice I have my units though up here. That is to help you so you know, yes, I'm putting in molarity. I've got my moles over liters, and you should punch it in and we should be good. Again, the key was those words at equilibrium. Trying to see if I have a highlighter. I don't have one here. But at the very first 2 words in the sentence, it said we're already at equilibrium. You just plug right into K. It's just saying, okay, I know what K means. I'll pause again for questions. I have a question for you guys, just because before I started recording earlier during office hours, a couple people asked this question. So I'm going to ask it to you. What does that value of K tell you about this reaction?
Reactant favor?
Yes, thank you. Several of you answered at once. I'm going to put a note at the bottom. I didn't ask it, so don't answer it unless I ask. But if K is less than 1, then it is reactant favored. And then I have a second question, which is I can pause the video and give you guys like 15 minutes to try the second page a little bit, or I can just keep going.
Just keep going.
I'm going to keep going unless somebody, yeah. All right, we're going to keep going. All right. So again, we have a lot of numbers. It does not say I'm at equilibrium to begin with. So this must be all my I numbers. So it gave me a value of K here. And then it tells us we have a 2-liter flask and we have 2.5 moles. Please notice there's a unit. I am going to be doing moles over my 2 liters. And then my nitrogen is 1.5 moles. I tried on the test to do better than I did on your study set, and I spaced things. I think I did it on here too. In the equation, I gave you a little bit more space, so as you wrote stuff underneath in your ice chart. But learning to write in the space is helpful. All right. And that's all it gave us. And then it wants to know what is going to happen. So what type of problem is this? This is
Q.
Q. It is Q. It is Q. So if you're given all the initials, we have to solve for Q to figure out which way it's going to shift. You also recognize a Q problem possibly because it will ask what's going to happen once equilibrium is established. Q is the same as K, so products over reactants. So go ahead and write your Q expression. I'm not going to go through this whole thing. I'm just going to say I know my answer is good. But state your Q expression. This is what I mean. You do plug these numbers in as molarities, and you solve for Q, and we get my number. I then line up my K and Q. My K was up here, 0.036. My Q, you guys would go through solving for your Q. Just because of time, I'm not going to go through all that step. And then you compare these two numbers. The Q is larger. If this is my recommendation, and it was a trick a student showed me like 20 years ago, and it's actually quite brilliant. Alphabetical, K comes before Q. This will always point you for the arrow. So my arrow goes reverse. Because see how the sign is pointing that way, just like the arrow. And then at that point, we want to see what will happen to the hydrogen. The hydrogen this time is in the forward direction. So since it shifts reverse, we're going to decrease the hydrogen. So that's basically what you would have to show me. You'd show your Q statement. You would show how you plugged in. You would state that K is less than Q. It shifts reverse. What I was getting ready to do here, I like to write the word sometimes because it helps me, or helps me to communicate to you. In this case, often that's all I ask for, which way did it shift? Or which way does it shift? But I asked to take it one step further, and that would decrease the hydrogen. Okay, I'm gonna keep going unless you have a question. All right, let's make an ice chart. So we have 1.20 moles in 2 liters. I apparently was thinking about 2 liters on this whole test because everything seems to be in 2 liters. And that's all I gave. The other 2 I didn't mention. So their values must be 0. So write the zeros in. This means you have to move to the zeros because you can't have zeros in there. So my change, minus 2x. Again, the 2 is from in front of the SO3. The SO2 is plus 2x, and the oxygen is plus x. All right. So at equilibrium, 1.2, this will be 0.6 minus 2x, and put a line. This will be 2x, and this will be x. So the initial plus the change will give you what the value is at equilibrium. All right, and then it gave us another piece of information. It said 75% decomposes. So initial times percent equals change. This was on the worksheet, the very first question on worksheet 1. And several of you, I commented, please state the formula. And some of you did it kind of reverse engineering, which is fine, like reverse osmosis, but it is really this simple. This goes with when we get to some of the stuff with the acids and bases. Initial times percent will give you the change. So my initial was 0.6 molar. I'm going to multiply by the 0.75, and that will give me my change. I actually want that number. That's 0.45, right? Yeah. So this is where you have to be careful. We're talking about this first column. In that first column, the change is not x. The change is 2x. So that is equal to 2x, and from there you can find x. You can finish this whole row here, and then you plug into k. So state your k formula first, and then we plug in all these numbers and you solve, and you should get k equals 2.0. I'm not going to actually walk through it right now. I've given you enough how to do it. A couple comments. Some of you, about half of you, can show me your work in a very lovely, logical way. And some of you, it's all over the place. So if you study and you practice, take a deep breath. This is just a chemistry test. That's all it is. And do it calmly. And it is being able to show your stuff in a logical kind of way. So again, make your ice chart, and then underneath of this column, I even said initial times change, and I labeled it. I would then solve for x and have these values. State your k formula, products over reactants, plug everything into k, and you're good. You solve. So there's not a lot of work. You should be able. Questions. Probably the most missed point on this question every year is people don't tell me their K expression. This is what I mean by always state your K expression, the products over the reactants. So state your K expression, then you'll plug in and you'll solve. Was there any questions before I move on? And if you have a question, you can set up your next ice chart. Go ahead, Aaron.
I was wondering if it's a 0.45 minus 2x or 0.45 equals minus 2x.
It is what I just said. 0.45 equals the 2x.
Mm-hmm.
Your question is if it's a negative 2x, that doesn't matter.
Okay, cool. Yeah, I just wanted to, or it doesn't matter. Okay.
This is going to be 0.15. This is going to be 0.45, right? This is going to be 0.225. Is that what you're asking?
Yeah. Okay.
Does that make sense? Because this column is 0.6 minus 2x, and my 2x is 0.45.
Okay. Okay. Yeah,
This
that makes
sense. Is 2x, which is that, and then this would be half of 2x, so 0.225, and then you would plug in.
Isn't 0.6 minus 2 times 0.45 minus 0.3?
It's 0.6 minus 2x.
And wouldn't 2x be 0.9?
No, 2x.
Oh, 2x is 0.45. Okay.
Yeah, thank you,
Sorry.
Catherine. No, that's awesome, because you probably, other people listening probably have the same thing. The point, her question's really important. The 0.45 is 2x. Yeah. All right. And again, I'm gonna move on. And again, this is why I will have an office hour tonight and the hour-ish before each time of the exam. So if you have questions from this, any of your study sets, any of your worksheets, anything from the notes, just come in, just do it and be relaxed. It is just a chemistry test. You've got this. You're going to do great.
Miss Sherpa?
Go ahead.
A quick question actually about that. I think maybe other people might have a question about do you want people who aren't taking the test at noon to show up at the noon office hour, or do you want to focus on just students that are taking the test right then?
You can come. Again, once the test starts, only one person will be admitted into my office hours at a time. So you are absolutely, Erin, having done this last term so many times, I'm usually just sitting here by myself for most of the tests. So if you are not taking the test at noon and you want to come to ask me questions, you just have to be patient because only one person's going to be in there at a time. And then if somebody does show up who is taking the test, I'm going to ask you to leave so that I can answer them. But yeah, so you can come and ask questions about other stuff if that's what you're asking.
Yeah.
Yeah. Yeah.
Awesome. Thank you.
You are very welcome. But I think you guys, you're all going to be in great shape. All right, I've pointed this much of the sea. I need an ice chart. Reminder, my ice chart has units. So this time, I did this one on purpose. I gave you the product, and there's nothing about the reactants. So the reactants are 0. The arrow is moving reverse. My reactants are my plus x, and my product is my minus 2x. So E is x, 0.5 minus 2x. I did that on purpose to point out, we just write an equation, we say, we start with the reactants, we end with the products. But then once that equation is there, don't flip the equation, don't change anything. I want the answer for how it's given. So my minus 2x is on the product side because that's where it started for this. All right, you write your k expression, which is simple here, c squared over a times b. And this is where you're going to plug in. I am going to go through this for 2 reasons. We plug in the k. We plug in, we have 0.5 minus 2x squared. And then this is x times x, right, which is x squared. You can write it as x squared or x times x. Now, at this point, half of you are going to actually write solved with TI Inspire. And then you'll say x equals. So if you were somebody who has one of those fancy calculators, you're going to tell me why you're missing these next steps. And so you would say you solved with it. Those of you who do not, you have to get rid of the squares. You have to square root both sides. So you're going to have the square root of 15 equals, remember you're square rooting everything. So all the squares are gone. You rearrange and solve. It really only takes a minute or 2 longer, and you'll get your x. And then I asked for the total pressure. That's interesting. And it came out the same. That's pretty interesting. That's a coincidence. That's not going to always happen. It's because of how the numbers I picked. But you would do the pressure, once you find these, you'd plug them all in and add them together. Yeah. And again, back to the question, I will be here in office hours while you guys are taking the test. If you get stuck, what I would do is move on your test, or you can check into office hours and say, hey, I'm going to need help on number 6. And I will do my best to give you a hint. Or if you actually ask, say, I got to this point, blah, blah, blah. Sometimes if you hold something up to the screen, since we'll only be the 2 of us in here, you'll be a nice big box on mine. I might be able to point you in the right direction to give you a hint, or to say, yes, yeah, you're on the right direction, just keep going. So.
Dr. Sherpa, so for this one, we don't need to use the gas laws equation?
No,
okay.
Yeah, you're not going to use that on the test. I do that again on worksheets and study sets, because that way at the final, we're not trying to remember all these pieces and stuff. But it is also back to what Samantha's question is, It says KP. See the little P there? That means you do want to use ATMs. So keep everything in ATMs.
I thought I remembered something where you said if we're going to do the ice chart, then it needs to be in molarity, but maybe if we're doing the KP, then we don't need to worry about that.
It probably was. I said that because I said, I may have said unless it's a KP. Or I may have said we'll do a KP later and see ATMs or something. And it may have been where I'm mumbling to myself up in front of the video and you don't hear my mumbles yet. But yeah, if it's a KP, you use ATMs. And if it is any other K, if it doesn't have the little P there, you use molarity, moles per liter. If it doesn't have anything after the K, oh, these guys all did. KC is molarity. KA and KBs are molarity. Yeah, good questions. Anything else before we move on to acids and bases? And for those of you who are here, I'll hang out after we're done also. So if you have individual questions, and I'll be back this evening, that I can always walk through any one of these with you or anything. Go back over the study sets and stuff so you feel proficient at these, because the same problems seem to keep showing up. All right, acids and bases. Next page. Let's walk through it. This would be in multiple choice. It would say pick the true statement. So A is false, and that's a terrible question. And can we just cross it out? And if you really want to know why it's false, an example would be any of the transition metal ions. They act as an acid because they pull hydroxide out of the water. So the water is left as hydrogen ion. And it's because they can form complex ions. So it's a terrible question, but it is false. So you can just write a big frowny face and say that's an evil question. I think I say that every year, and yet I haven't deleted it. The second one is also false. And it's that word always. And you know, I'm pretty sure I avoided questions like this on your test. I put it on the review just to point out when you see something with a negative charge, this is back to the question you were asking me earlier, Aaron, things with a negative charge, and we'll get to it on the next page, anions will often act as a base. But again, notice the use of my word there. I said often. I did not say always. An example of one that does not have a negative charge is NH3. Ammonia is a neutral compound in terms of it does not have a charge. It is definitely a base. All right, E, this is important. If you dilute an acid or a base, you change the pH. That is absolutely true. Dilution means you've changed the volume, you've changed the concentration, and so pH is the negative log of the concentration. It changes the pH. All right, the next one's a really important question. And this was the bottom of page 14 in your notes, where I talked about metal oxides and non-metal oxides. And this is before they are made into anions and cations. The 1As and the 2As, the metals, are called alkali metals. They do not form acids. As metals, they form bases. This is not ions. Metals form bases, non-metal oxides form acids. So that one was false. That's like a big take-home question. You probably learned it back in 221, but you didn't realize it. The 1As and 2As, again, are called alkali earth metals and alkali metals. All right, the next one's false also. Wow, I must have just been in a false mood here. That's the conjugate acid. So if we were going to make the conjugate base means you need to lose a hydrogen. So this one gained. All right, S. This must be like they're all false. I'm laughing at myself because I don't even know what the questions are going to be, and I keep getting all these that are false. All right, the next one is false because as soon as you see nitrogens, you guys see nitrogens, you're going, nitrogens like to be bases, so it is not an acid, it is a base. Does anybody remember the example of a Lewis acid? There's a classic one. It is boron. So a Lewis acid is where you're missing the electrons. All right. H3PO4 is amphiprotic. That is false. So being careful with the words here. H3PO4 is polyprotic. So poly means multiple hydrogens. So I'll just put next to it, yes, polyprotic. It has 3 hydrogens. Amphiprotic, that is when it could act as an acid or base. This is not amphiprotic. We will see examples of amphiprotic on the next page. Actually, these guys up here, those are amphiprotic. They have hydrogen and they have a negative charge. All right, so far only one true. So, oh, the next one's true. Hooray. If you're acidic, you do have more hydronium. That's the definition. This is back to a question many of you were asking me earlier, and I think it's a bigger picture thing. I think it was Sam, you were asking me. It has to do with that first post-lab question in the lab, and it said what ion is responsible, and it's the hydroxide. These are really small concentrations that are ending up in there. So just, it's just this ratio of hydronium to hydroxide, whichever you have more of, that makes you an acid or a base. And so an acid has more hydronium. Why is the question, the very first question in your lab, it is true. Cleaners are bases, and that makes them soapy. Sam asked me the question earlier because some of hers were showing up as acids, and that can happen. All right, the next one's true. Oh, I must have like changed my attitude, and now I'm being all true. Fruits and vegetables are acidic because they have a sour taste. Sour means acid. All right. S is false. This is a Lewis acid. Again, a Lewis acid, it can accept electrons. So Gilbert Lewis, he looked at everything in point view of electrons. So a Lewis acid accepts electrons, a Lewis base donates. All right, we're back to all the false ones. So R, Y, and I were true. This is false. Only this hydrogen comes off. It's organic. The hydrogens on the carbon are nonpolar. They don't come off. So just that hydrogen after the double O, oxygen. I'm pretty sure that's true. You would have to do just negative log of the HCl. If it's a strong acid, you can punch straight in. So what is this log? Yeah, so true. All right. N is false. As you go down on the periodic table, you increase the atomic size, and you make it easier to pull off. It's easier to remove the hydrogen. So the iodine, because of its size, it is the most acidic of the halogens. All right, and then the next one is true. It's called the, I think, the inductive effect. As you increase the number of oxygens, the oxygens become more and more greedy, and they create a greater polarity. And so it all has to do with this polarity. The more polar, the bigger the pool, the easier the hydrogen is to pull off. That is true when you're working with the oxygens. All right. I keep going unless somebody has a question. Oh, I guess I had to circle that question mark too. Again, these questions were like a multiple choice. Yeah, don't overthink them. It's just a test. All right, looking at the little box. We had one of these, I'm pretty sure, in the notes and in your homework. The difference about this box is they are bases. So lowest pH would mean the least basic. The most acidic. Right? The lower the pH, the more acidic. So which base is the least basic or the weakest? It looks like it's the middle one. So that's our weakest. And again, the lowest Ka, which is the aniline. I'm sorry, Kb. Kb. Aniline, aniline. Sweet aniline. All right, Joey giggled. Which base? You guys are all muted, so I can pretend like you all were giggling. Or you were panicking that I was going to start serenading you. All right, which one has the lowest pOH? Oh, this is a really good question. What is the relationship between pH and pOH? So remember this little formula. This is more explanation than you need. But this should hopefully help some of you to think about it. pH plus pOH always equals the magic number 14. So as the pH goes up, the pOH will go down. They are opposite scales. So the one with the highest pH will have the lowest pOH. And so that would be the most basic one. You can also think of it just like pH, the most acidic has the lowest pH. The pOH scale, which nobody uses, tells you the lower the pOH, the more basic. And so that would be the strongest. The most basic would be the highest Kb, which is the methylamine. In our little chart. Question C, strongest conjugate acid. So this formula. Those two formulas I just wrote, they need to be like ingrained in you, so they just are second nature. Sure, you can have a note card and stuff, but they just need to be there because we use them so much, not just for this midterm. This midterm's to get us through the rest of this week. And so Ka times Kb equals 10 to negative 14. The stronger an acid, the weaker the conjugate base, or in this case, the weakest base will have the highest conjugate acid. So as one of these goes down, the other goes up. So the weakest was the aniline, or sweet aniline. All right, and then the next one is, so On Friday, a lot of really good questions were being asked during office hours. And again, you need to go back either over your study sets and your worksheets if you have time, ideally. So when you take the test, you just do it and you're done. If you feel ready at noon, absolutely, you're welcome to come and join that group. If you feel like you want to keep studying all day, it's kind of up to you. Anytime you see this little p in front of anything, it is just telling you to do what function? Negative log of whatever comes after it. So POH is negative log of the OH. So it is negative log of the KB. Because of that negative, it's always an inverse relationship. So the highest PKB is going to be the lowest KB. It's because of that negative in front of the log. It's the same with pH. The lower the pH, the higher the hydronium. So whatever the negative log is doing, there's an up and down relationship. So is this the sweet aniline again? Sweet. You guys can all like. All right. So yeah, A, C, and D were all the weakest one. And then B was the strongest base, the methylamine. All right. In the homework, and I think on your notes, we did this with acids. So you'll see this. You might see it on both tests, actually, on the multiple choice and on the show your work. I can't remember now. All right, let's write equations together. One of the things, the strong acids, you want to recognize them. And again, so you can make a note card with things that you want. What I would do is like what they do in physics, is just have one page of the things you want to have handy. If you're going to be trying to go through all your notes, you guys don't have the time. So H2SO4, that is a strong acid. Acid always reacts with a base. This is a base. HCO3 with a negative is actually amphiprotic. It could have been an acid or base, but strong acid makes the other thing have to be a base. It was a question I think Baker had asked me last week. It is always an acid-base relationship. You can't have an acid-acid relationship. The reason it's important to recognize a strong acid, one arrow, one-way reaction. Strong acid means completely dissociates, completely donates, and also you only do only one hydrogen. So HSO4, you lose one, you become a negative. And that hydrogen goes to the base, so it becomes H2CO3. The acid becomes the conjugate base, the base becomes the conjugate acid. So kind of back to the question Erin was asking, but not exactly this question, but I think this might help when we get to the next page. It was on the next page. When you are writing a chemical, these equations, for the acid-base stuff, the only time you guys are writing equations for this midterm is on a question like this where I say, write the reaction. And in that case, what you start with is the acid and the base, and what you end with is the conjugate acid and conjugate base. When we get into the problem solving, I mentioned that because when we get into the problem solving on the last page, you're not writing out the reaction, you're just writing the Ka expression and going with it. There is one more step with this one. And if this showed up on your midterm and you caught this, that would be awesome. If you forgot, it would be like half a point. I think in the past, I've made it a half a point bonus for the person who catches it. It has to do with this carbonic acid is unstable. This is what keeps the pH in our blood balanced. And so this actually becomes H2O plus CO2. And so we can regulate our pH by our breathing. And you guys have another challenge, another 7-day challenge. I have no idea when it's due. I'd have to figure that out. Anyway, it's a little bit different, but this is where one of them has to do with breathing. And so this was the question Aaron and a couple other people from last term had asked. So when you think breathing and you're in my class, it has to do with meditation. You get a choice. I'm not forcing you to meditate, but that's really the only purpose of any of this, is that you should. Anyway, your breathing changes your pH. Right. You guys see the COOH? That H I underlined, this guy is an acid. If it was a base, carbon hydrogens, you would see the nitrogen. So remember, nitrogens, we're thinking base. Water then is the base. This hydrogen after the double oxygen comes off, and we have 2 arrows because that is not one of the strong acids. And again, you guys be forgiving of yourself. Like having the arrows, the correct arrows, that's like half a point. So if you don't have to be perfect. Some of you do, but I don't. Or you just videotape myself making mistakes. So, all right, that's my conjugate base. So the C6H5 does not change. The COO becomes CO2 with a negative, and the H2O becomes hydronium with a charge. That's it. We have one more step. And that is because there's double arrows. I will ask you, show me which direction is favored. On A, you've already answered that. There's only 1 arrow. So it's obviously going in that direction. On B, if you don't see a strong acid, then you're looking for the next strongest thing, which is either going to be hydronium or hydroxide. Hydronium or hydroxide are going to push it reverse. It does go both ways, but mostly reverse because of the hydronium. And there is a third possibility. That's not going to happen on the test, but that is where you would then have to look up KAs and compare them. All right. Unless there's a question, I'm going to flip this to the last page. Questions? You can always take a screenshot, apparently. All right, we're going to do math. I'm not going to walk through every step on all of these. I'm going to give you enough that you can solve them, or you can ask me a question whenever you want. The issue with number 9 is that number 2 there. To do pH, we are going to do POH because this is a base, right? So we're going to do where we do our pH plus POH. I'm writing it way over here because this is going to be my last step. I have to get to that step. So I'm going to first find my POH. To find my POH, I need my hydroxide. I am going to label my work very well because on the math part of the show your work, you're going to all label your work beautifully. I need the hydroxide. I only need 1 step, actually, I just realized. For every 1 mole, this is one I think I did in the notes and people had a question on, maybe. Maybe not. Maybe it was in the homework. I don't have to mess with grams and the periodic table because it's already in moles. If I started you with grams, you guys know what you have to do. It was all over the worksheet. If I start you with grams, you guys want to have, when you start on any of the tests, have your periodic table ready. Have it up and ready. Hopefully you have a printout of one. Change your grams to moles. The math for Ka and Kb, you have to be moles per liter. So I just have to double this. So 0.0826 is my hydroxide. So that's my first step. All right, I'm going to go up here. My second step would be I would do negative log of the hydroxide. That's my POH. I just realized I'm off the screen. So this number will plug in there. I'll get my POH. That will plug in there. And the answer is 12.92. So a question that 2 different people asked me about earlier today. Please give your pHs to 2 decimal places. The question that came up was about sig figs. And you can go with the 3 sig fig rules for everything. If you gave me this as 12.9, I would more than likely give you full credit. But once we get into buffers, you got pH, a small change in pH out here can actually make quite a difference. So just get in the habit of giving pHs with 2 decimal points. If I ask, does the answer make sense? Yes, it's a base. pH of a base is above 7. It is a strong base because it's a hydroxide. So we should be getting a pretty high pH. I know I didn't ask if it makes sense. All right, the next one tells you it is weak, and it wants us to solve for Ka. So state the formula. You guys hopefully know it. If you keep stating it, you just know it. It makes our life so much easier the rest of this week because we are already there. You can just write A, or you can write WA for weak acid. These are always x squared. But we're not solving for x this time. If I give you the pH, you guys know what to do. So 10 to the negative pH will give you your hydronium. That is going to be that number there. In this chapter for this midterm, this is why we have a midterm before we get into buffers. These 2 numbers are the same. So your hydronium is the same as your conjugate base. That wonderful piece of information will disappear on Wednesday, but it works beautifully for your test. So how I set this one up, this is more, if you like this, you can do it this way. You can absolutely find this number, but I actually put it in my calculator like this. And then 0.025. That's how I set it up, and I punch it on. That's a 4.3 to negative. This is more, I can't remember who all, we were talking about this on Friday. I had a conversation with more than one person. It had to do with rounding. And when you break things into multiple steps, the amount of rounding ends up making our answers different. So learning how to put it all in one setup. So I just write this as 10 to negative 4.30, and then I square it and put it over that. I get an answer. That is not the final answer. So you would then have to do the negative log of your Ka will equal your pKa. Oh, and apparently it came out as 7. So once you found this number, you would plug in to there. I'm hesitating because if I write down like every step, then you guys are furiously writing down every step and you're not thinking as much. The comments I wanted to make on the worksheet, having gone over, graded the worksheets yesterday, about half of you were being a little lazy and we're not stating your Ka formula every time. It's not going to be that many problems on the test, but state your Ka or your Kb formulas. State your formulas as you use them. Say, okay, I'm going to use this formula now, and then show me what you plugged in. Now again, if you want to show this is step 1, and then step 2, and then step 3, you can absolutely find out what that number is and then plug in. I was just showing you a way that you could eliminate showing that step 1 and putting it all, well, not eliminating it, but just putting it within the problem to deal with rounding. All right, let's move on. Number 11, it's another Ka. You'll state your formula. Multiple choice, you can be as sloppy as you want. All I'm going to see is your answers, or the computer. I don't think I even see them. Very bizarre way to be a teacher, in my opinion. This is an x squared. 0.34 is that. The Ka is there. You plug in. Now, this is a quick comment for all of you. When you solve for x, tell me, that is actually not me, tell yourself it is the hydronium. So you'll say x equals, you'll get a number, and then you'll do negative log of your x equals your pH. Okay? It is either going to be the hydronium or the hydroxide. Up here it was the hydroxide, here it's the hydronium. You want to label that, because again, I know where we're going the rest of this week. It is a question that Aaron has asked me today about, I'm about to do number 13 where we flip-flop. On Thursday, on Wednesday and Thursday, we keep flip-flopping all the time. So you got to be where you're going to be okay with me flip-flopping between Kas and Kbs. And that's what this is a precursor to. And that is why I stop at this point. We do a midterm here. So you feel comfortable here and we're ready to move on. Otherwise, you never like get the flip-flopping. So there was a second part on the test. I made it as a second question, and that was the percent ionization. So the percent, and again, it is an incorrect term. Acids and bases do not ionize, they dissociate. It is the change over the initial. So again, right, back to the percent from the second page. In this case, the change is the X, and the initial was the acid. So the 0.34, and the X was whatever my X was, times 100, and you should get my percent that's given there, around 4.5%, just under 5%. All right, we're almost done. Unless there's any questions up to this point. Again, I didn't want to show every single step, but I do want to remind you, state your formula. All right, number 12. This is ions. This is different from the covalent compounds. You're going to cross out potassiums, 1As and 2As as ions, no impact on acidity. 1As and 2As as metals, neutral metals or metal oxides, that's when they are their alkaline nature. So different from this where we're now ions. All right, the other thing I cross out are the conjugates of the strong acids. So HBr is a strong acid, so Br can't go back, so it's crossed out HI. If you are left with the cation, it is an acid. If you're left with the second one, it is a base, anion. So the positive transition metals act as acids. This question Aaron asked me earlier. This is the conjugate base of an organic acid, the CO2. The H would replace, the K replaced an H, so that's why this is a base, because the hydrogen's missing from the end there. All right, and then this was a question I think Trish was asking me. So you are left nothing to cross out. So all you would tell me is you compare Ka versus Kb. On the study set, I actually looked up numbers and I wrote them down for you to show you how I was comparing them. On the test, that's all you're going to tell me. I would compare Ka and Kb. I do not need you to look them up. Just move on. You've got the idea. You all, I trust you all know how to look them up. So just tell me what, that's why I said what info would you need. I am approaching this test as if we're in person. And so I'm not going to make you go and start looking up a whole bunch of information and see who has the best Google skills. That seems ridiculous. All right, number 13 is everybody's favorite. And if you're really good, stand on your head, because this is the one where it flips. And this is a question every single one of you has been asking, and some of you have asked me actually, and some of you've all thought about it in your head under your knob. This is where it starts out by talking about saccharin, and it tells you it's an acid. It gives you a Ka value. And these are the ones, somebody said, these are really wordy. You go, oh, this is going to be one of those ones that flips upside down. And then suddenly it adds a sodium in there. That means they suddenly switched from the acid to the base. So that is why I said, is it an acid or base? It is now a base. This is where it flipped. When you added the sodium, you took off the hydrogen. So you guys see that hydrogen at the very beginning there? You took that hydrogen off, and we now have, these are really hard. And every single one of you who was asked this question, which is every single one of you, whether it was home or at home and in an office hours, but hopefully by tomorrow you're just like, oh, this is where it flips. So the sodium knocked the hydrogen off. That's my formula. It is now a base. You have to use Kb. The only thing that's present is the base. So you have to change the Ka to the Kb. I'm not going to go through every step. I'm going to go through a couple ways you can change the Ka to the Kb. I gave you pKa. pKa plus pKb equals 14. It's a wonderful, wonderful formula. These formulas all start looking the same. That's what I do. I change my pKa to pKb. Now, showing your work. So this was something, I can see some of your screen names right now. So like Baker said, I write really big, it doesn't fit in there. I don't need to see every step. State the formula, and then you can just tell me, okay, my pKb then would be equal to, because I'm trusting that you can subtract. So what would that be? 11.68. So you're stating what you did. pKa plus pKb equals 14. So my pKb is this. And then 10 to negative pKb equals your Kb. And then you would just tell me what the number is. If you do it that way, I just write it as 10 to negative 11.68. And I leave it like that, because your calculator is fine with that as a number. I don't actually care what the Kb value is. This is more, this is back, Aaron, the comments we were talking about Friday. This is more precise than giving me a number, because your calculator will have the whole number there. All right, so see how that's nice? We can have it right there in one little area. Now I'm gonna state my Kb formula. You guys, if you keep stating these formulas as you practice, it's there in your head. You don't have to look at any note card. You've got it. We do a lot with this on Wednesday, Thursday, and Friday. You just want to be where this is really smooth. You've got this. You've all got this. All right, it's the opposite of the Ka. So instead of conjugate base, I have a conjugate acid. Instead of hydronium, I write hydroxide. Instead of acid, I write base. It is the blessing that the test is tomorrow. These are x squareds. After tomorrow, it changes. For your midterm, when you get to the acid base, weak acids and weak bases are x squareds. So how I would solve this is I would show 10 to the negative 11.68, this is my Kb, equals x squared over, oh, you know, you're gonna have to figure out your molarity, the grams changing to moles. This is gonna be your molarity. Then you solve for x. Your x is gonna be some number, blah, 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 blah. You're gonna give me the number. And a reminder, always tell me, what does that x mean? This is a base. My x is hydroxide. So up here, my x was hydronium because it was an acid. We're dealing with a base. My x is hydroxide. And then you would do negative log of x. That is not pH. You will know it's not pH because you're doing this very calmly. You just said, I'm working with hydroxide. This is my POH. And then you would just state pH plus POH equals 14. I don't need to see this step, just state that formula and you should get my answer, 11.33. Now back to a quick comment. And again, it's who I can see on the screen. I feel you should be able to fit, I didn't give you very much space on this handout, but if you feel when you're doing the test, some of you are going to be able to print it out and some of you are going to do it on a piece of paper. You know, try and keep it within a nice logical way in there. And if you're somebody who knows that you like to write big, then don't print it out. Just do it on another piece of paper, but please put it in the order that it is on the test that you have. There is a question tucked in here that would be there more obvious. Does your answer make sense? Of course it does. So I think I tried to phrase it different. Explain why the answer makes sense. It is the salt is basic. So the pH is greater than 7. That's all I'm looking for. When we put the sodium on, it became a base. We lost the hydrogen. So my pH should come out above 7. It did. We're good. Do one more with Le Chatelier's, unless there's a question. But most of you are looking tired and you probably just need to take a break. But let's go ahead and do 14 real quick. I think we did this one already. All right. So if you remove the hydrogen, it's going to shift reverse. If you add more H2O, no change. So again, Le Chatelier shows up on both tests. As somebody really kindly said to me, when I'm doing it, it looks so simple. You would hope when your teacher's doing it, it should look really simple, and it is. Just my best advice for you guys when you take the test, 2 things. One is don't overthink it. Having a time limit is a blessing because I'm not allowing you to dwell on stuff. You just got to do it and move on. And I think the second thing is be forgiving to yourself. It's just a test. And move on. All right. On C, he sits on the flask, so we increase the pressure. So it's going to move forward, right? We have 4. moles. And here we have only 1 mole. So forward, ice, this is endo. So ice is going to shift it in the exo direction, which would be reverse. And then which ones will increase the CO? So basically it's asking which ones will make it go reverse. See if I do it right this time. That was A and D. So A and D shifted it reverse. And then F, just because I've done this long enough that everybody always has questions about the temperature pressure thing. Endothermic, we want a high temperature. So high temperature and pressure, we already said pressure pushes it forward. So we want a high pressure. And that's it. Can you even see what I was doing? All right, and there's fairy dust, because fairy magic is always important, especially on a full moon. And tomorrow there won't be as much gravity because the moon is getting smaller each day. And yeah, the full moon was this morning. I already feel better, so is Rocky. Are there any questions? I'm going to stop recording. And I should ask if anybody noticed the cockatoo in the stop.